Too slow. Nice world. Too slow. No, I'm not going to change that. Instead, I'm going to speed it up. The shader. I could actually make this frame rate dependent on what you do. I'm not. Well, I'm not going to. If I'm not going to, I don't have to add it here. Okay. I don't have to add it here. Oh. When will I remember? Okay, I can't, I can't do a tutorial commentary while actually coding because the cognitive load is just too great. But I'm actually coding. Well, I can say what I'm doing, but I can't explain it. Save desktop. So after this crashes or I close it, I'll still have access to this file. Okay, all I have to do is make this color darker. Say 100. Make it 50. See how that works. I could put a frame rate dependent. No, that's not going to work. Because I didn't free. Okay. That means nothing. Just try again. Okay. Well. nice, but doesn't really help speed it up. So I think, yeah, I mean, I can talk while I'm doing this, I just can't actually explain it. I just can't actually... Okay, so that's too complicated a space. So we'll just simplify. I always simplify. Yeah, I put the little thumbnail of the second screen up in the upper left corner because, let's see, it shouldn't be in the upper left corner. It should be, because that's where I put the render, it should be in the yes, it should be in the upper right corner. Right. And a little bit smaller. I just want you to be able to see. Just makes, okay. It should be there. Good. Now the tracer is clearly visible. Okay. Okay, now we're getting better speed. Okay. You can see the milliseconds over there, 66 millis, 70 millis, so we're getting 15 frames a second.
Good morning.
And this is still not fast enough to feel good. So, let's see. I will shoot a quarter as many rays per frame, but it will not speed up by a factor of 4 or anything like that. And the reason is that I'm shooting as much rays, but I'm essentially touching the same amount of memory. So, and I could expand that window because the GPU will do that at essentially 0 cost, but there's no reason to. Well, now we're getting between 20 and 30 frames a second, so it feels much better. I would like to remind everyone that there is no lighting at all. I would consider lighting in here. That is, or if you wish, trivial lighting, where there's a directional light mounted on the camera itself, pointing at what it's looking at. So surfaces are lit or shaded according to the dot product of the incident ray and the normal of the surface. Now, whether that is the surface normal of the cube making up the surface, or the normal of the object, such as the sphere, that the cubes make, is a matter that depends mostly on how far you are away. Anyway, a very simple world. I like it. But we gotta be able to find a void with none of this sphere network in it. Ah, yes, here we are. And in this void, in this void we can draw. Now, all these spheres have shared all these spheres are shared. So, it's what people in the video game industry call instancing. So, if I draw that, I will find that that actually exists in every sphere. Although it's so small, it will be hard to find. I'll draw a bigger one. So, I'll draw a bigger one. I'll draw it into, right. So now, we should find that block is drawn into every single sphere. And now, let's just draw a line I mean, the idea that, I mean, clearly you could not do any of this with a rasterizer. Behold, I can put the rays closer together, in which case it becomes impossible to navigate. I can move the rays further apart, in which case the world becomes fish-eyed. can make holes. I can make holes of any size. In these, any size is an exaggeration. I can't make holes in any size in these objects because they're not ordinary cubes, they're n cubes. So once we have a massively occluding world like this, the frame rate becomes more consistent actually. Because while division of space, which is necessary to draw detail, slows the renderer down, as long as the ray has to traverse extra steps of empty space, it speeds the renderer up when it hits detail and stops tracing the ray that hits. I find the interference effects quite beautiful. The interference effects on the fractal, on the SERP cube. And you say, why interference effects? Because we don't have two screens or two gratings. We have a Sierpinski gasket that is popping into levels of detail. But what's it interfering with? Of course, it's interfering with the rays. The rays are in a pattern. So we have a grid interfering with not another grid. Well, a spherical grid. We have a rectangular grid interfering with a spherical grid. So it's not exactly like the sort of chain link fence interference we normally see, in that you get this intensification at a circular patch in the center. But that's also a result of the level of detail which looks for them. Quite beautiful. Okay, time to make something else. Let's see. Okay. So we got this dot. And we're distributing the dot around the world, which I call the marsh, the cosmos. We're distributing it around we're drawing it around using a noise function. So first, let's make the world So, for instance, I will change the density of the mist in both the world and that object, just because I want to show. Actually, I'm doing pretty well at demoing, aren't I? Rest your mind, doesn't matter. So here, well, this is nice, but it's not showing anything like what I'm trying to show.
Good morning.
Okay, so we're going to take an ordinary block, not that thing, and make it axolotl. I think axolotl. So we're going to take this SERP. I know that will work. And make it the voxel is drawn instead of eyes. See if this works. Oh, we're not inside it. Well, that's not going to work. So this yeah, what people want from a stream is a stream they can watch reliably. Let's see if people like a game stream they can watch hours a day, or they can turn on and watch whenever they feel like it. Presumably the same would be true for coding streams if there was anybody who enjoyed watching coding streams, which there may be. Okay, forget the noise. See what this does. that doesn't seem right. This definitely seems wrong. We may have to I don't understand how this file gets corrupt, but it does. The desktop file gets corrupt. So we don't have our saved desktop anymore. We have to start from scratch, which is fine. Well, it's fine, except it's black, so we have no idea what's going on. We're not, oh, no, it's not black. So all of a sudden I saw something there. So, free, we'll try it again. Right. Okay, so here we are in a mostly empty cosmos. And we're getting hugely great frame time. I think, actually, I can run more rays. I'm not sure what I'm going to do in this world yet, but I think I can run more rays.
Good morning.
So I'm getting a 50 millisecond frame time. And what you're seeing there is just a reflection, it's just of the subdivision of space and the fact that it's colored space. So, is that the correct way for colored space to look in blocks? Well, we don't know. Ah, beautiful. Beautiful. Right. We can't enter the SERP queue, which is good because it turns out there's a problem with putting the camera inside a fractal. That is the blue sky that separates the world from what's on the other side, which is just a repeat of the world. Unfortunately, because the mist is so dense, you can't see actually what's going on there. So Ah, yes. The secret to streaming is one talks as if one was talking to one's favorite person. And in this case, that's not far from the truth. I am talking to my favorite person. So what I've done here is drawn a sphere out of these things, these quasi-Sierpinski cubes. I've drawn a sphere. Now I'm dropping under the influence of gravity, which I'll take off because it's inconvenient. Right, there's no gravity anymore. Now I can just move. I've drawn a sphere, but the sphere is drawn to the center of the world, and the world is a cube, and the sphere is large. The radius of the sphere is larger than the radius of the world, and so it clips against the edges, and you don't get a complete sphere, so you get these arches. So that's pretty clear. Well, this just takes some practice. I actually don't know why I have an alpha value in the color. I'm not sure what it does. I've made no changes except I've just changed the color on that mist. Let's see what happens. And I didn't save the desktop, so I have to get it back. System. Save desktop. Retina. Over-under. Marsh. Save desktop. At least these will be back if I have to reopen. Okay. Ah, 20 frames a second, which is what I'm streaming at, so that's not bad. Yeah, when I first saw this, I mean, I was astounded. I mean, I had no idea that it was possible to do this. I mean, how could I have? But when I first saw it, it was, you know, in a very small window with many fewer rays than this. And I could see that it was beautiful and that it would work. But I never managed to convince anyone else. However, I think I'm gonna get the hang of this streaming. I can explain just fine while streaming. I just can't explain what I'm doing when I'm actually like working on the code. But I don't work on the code all the time. I fly around a lot, and when I'm flying around, I can talk. Notice it looks better in a way when I orthogonalize the camera, but it's harder. It's easier to lose my position in space because the solid angle taken up by the camera is much less. I attempt to compensate by making it more difficult to move, by making the camera more sluggish to move. Anyway, maybe we should work on this Rapinski.
Morning.
Okay, I finished. I'm done in the kitchen.
Okay.
Just wanted to let you know.
Yeah, when I can concentrate on this and listen to music, which will not work for long.
I'm just letting you know about...
Yeah, okay. Okay. I'm feeling okay right now, so I'm just gonna keep doing this for a couple minutes.
Why? What? Oh, bye-bye.
Ah! He was just getting nice, too. Nice and it crashes.
What?
We're moving from powers of 3 to powers of 2 here. Let's see how that works.
Okay. Oh.
Raster, bind. Okay, this means nothing. We'll just... After that kind of trap, I can just retry. I don't know what causes that. But it doesn't cause any persistent problem. Well, we're stuck in something you can't see. So the only thing I can try I'll move back to I'll change back to 3 space, M3 space. Usually I can't listen to music. No, that's not going to work, obviously. 81. .66 milliseconds, that's promising. Okay, so here we are inside a noise structure. So I've made this with essentially Perlin noise in 3 dimensions. I don't know if it's exactly Perlin noise. So this is nice. I want it to be much faster though. So it's just it's too halting. Doesn't feel right. And I'll make the window. The window will be big but fuzzy. Let's see. Again, this is not going to be 4 times as fast. Wait, what? I had too many windows there, I'm not sure what happened. failed to free something. Alright. It's astonishing that I've managed to listen to music for so long, but that's it. Can't do it anymore. No, I'll listen, let's see. I'll listen to the whole stub up modder. Okay, so here we have, it's full screen, but it's hugely expanded. So the detail's not great. But the sense of immersion is nice. So this is like a super Minecraft. It's the same kind of noise that makes caverns in Minecraft. And there's no shared structure here, so we can make holes and they won't appear anywhere else. Of course, when I'm just drawing an empty block to make a hole. This gives an idea of the speed. This is, coming in at 30 frames a second and coming toward full screen. So it's something like the resolution and speed that would be necessary. Really, you'd want twice as speed. Certainly for VR. And then, of course, I wrote all that. I'm using keyboard commands to make a smaller hole, a smaller hole. This is 3 space, so each of them is smaller than by a factor of 3. Normally in computer science one uses powers of 2. In this case I often use powers of 3, and the reason for that you've already seen. Because you can't use power of 2. You can't use powers of 2 division of space to make a Sierpinski fractal. So either you have to have everything divided into 3s, or you have to have some stuff in 3s and some stuff in 2s if you want to have Sierpinski fractals anywhere. And you really do. So for animation, moving objects, you would want to draw many voxel objects. Every frame you want to calculate like procedural animation and draw it. So I don't know exactly how computationally intensive that is going to be. I have not. I've done a little bit of animation, But obviously it doesn't take a huge amount of time to draw into these structures. These are transparent, let's see.
Oh, come on. Yeah, sorry.
Here we have green mist. Let's see. Don't want that. Well, maybe we do want that. So I have... Obviously the resolution here isn't great in that the smallest detail we can see is, 5 or 10 pixels across. But thanks to the GPU filter, so if we look at this unfiltered, that's what it looks like unfiltered. So you can see the blocks that are the size, what are those, like 5 pixels, 10 pixels? Those little squares you see. But if you think those are ugly, I don't, because I've worked with them for years. But, here we go. Here's the edge detector running on the GPU. There's Kantbot. Low resolution, but given his obsession with early Nintendo games, I don't think low resolution is a problem for him. I believe the SNES Donkey Kong is a particular favorite of his. Here we have a good, this is a good one. So let's draw a line of little spheres. Draw little spheres everywhere. Wiffle balls. Thank you. I feel so immensely grateful. Here's a Mobius picture. I know this looks low detail, but it's fun to move around at a high frame rate. It really is. Let's see. That's in mirror writing somehow. Let's just read one word. Yes. Yes? Say. Say, right. Isn't my paver is swimming on a hippopotamus? Okay, let's see. Now. Okay, so here we have a block, mirror dots, but we see dots, transparency, and around the color there's mirror. Interesting thing about mirror, it always looks perfect. You can't, once you implement a mirror, it looks perfect. That's the mirror. No matter how low resolution this world, this is, the mirror isn't low resolution, the mirror is perfect. Isn't that funny? What's in the mirror may be blocky, but the mirror isn't. It's perfect. It's a perfect surface. I mean, it looks that way. Looks like the pergolazi's over. I should have breakfast and stop streaming. Well, thank you all. You've been a wonderful audience. Like, leave a comment below. Yeah, subscribe. If you subscribe and send a nominal Bitcoin amount to the number listed in the screen description, you'll be eligible for you'll be eligible. You'll be entered in the raffle.